So let's take a look at this mechanics question, and here we are resolving forces. Let's draw out each step we are told. We've got a rough slope inclined to an angle of theta to the horizontal. So let's plot this in. We've then got a block of mass 5 kilograms. So if we draw this in, we know then we're going to have a weight of 5g, where g is 9.8. We also know we're going to have a reaction force from the surface of this block. So we're going to call that R. We're then told we've got a horizontal force of 20 newtons acting on the block. So we can draw this in here. And we know if we've got this horizontal force in this direction, our friction will be working in the opposite direction. That is parallel to the plane. So we can just draw this in like so. And that's going to have mu r. And we're told that the coefficient of friction between the block and the plane is 0.3. So let's start by resolving parallel to the plane. And let's go in the upwards direction. So what we firstly want to do is resolve our forces 5g and 20n. Well, we know that here will be theta, and on our 20n, if we draw in on our triangle, here will be the angle theta. So if we take a look at the parallel force, then it will be 5g sine theta, and the perpendicular force will be 5g cos theta. And on 20n, we're going to have that downward force there of 20 sine theta, and the parallel force in this direction equal to 20 cos theta. Now we've got that, let's go ahead and resolve for the parallel forces. So we've got one force that is heading in this direction, which is the 20 cos theta. We've then got two forces acting in the opposite direction, which is our 5g sine theta and our mu r. And we can input our 0.3 at this stage. So we've got add 0.3 r. Now let's take a look at resolving perpendicularly. I'm going to take the upwards direction here as positive. Well, we've got our one force working positively, which is our R. So R must equal the downward forces then. And we've got two downward forces working in the same direction here, which is 5g cos theta and 20 sine theta. Now we've got that, we've found a value for R here, and we can go ahead and plug this in to the green formula and equation that we've got above. So let's go ahead and do this. So we get 20 cos theta equal to 5g sine theta, add 0.3 multiplied by the whole of R, which is 20 sine theta, add 5g cos theta. And if we go ahead and expand this out by the 0.3, we're going to have 20 cos theta equaling 5g sine theta, add 6 sine theta, add 1.5g cos theta. Now we've got that, we can bring all of our cos terms onto one side and all of the sine terms onto the other. So we want to subtract our 1.5g cos theta from our right-hand side. So we get 20 cos theta minus 1.5g cos theta equaling our 5g sine theta, add 6 sine theta. So let's go ahead and expand out by g then, which is 9.8. So this is going to leave us then with 5.3 cos theta on this side equal to 55 sine theta on the other side. Now we know if we go ahead and divide through by cos and by 55, we're going to end up with sine theta over cos theta, which we know is just tan theta, and that's going to equal 5.3 over 55. So if you take the tan inverse of this, we're going to get a theta value equal to 5.5 degrees to 1 decimal place.